Hey Precalculus students, this is our first lesson of the unit. It's actually titled Lesson 4 in your notebooks, so maybe make a note of that for your binders. For this lesson you're going to need this handout, which you see on the screen, and you're also going to need your binders open to Lesson 4, which is page S10. So those are materials you're going to need. In general, this is the first introduction to our module, so we're going to be talking about the imaginary numbers, where they show up, and then we're going to dive into how they're used geometrically and algebraically. Awesome. So first, I just want to get us warmed up with some quadratic equation. So this should be review from an algebra class in your Do Now. We're solving just this simple one. First, we match up our coefficients, A, B, and C, and then our job after that is to plug them into our quadratic formula. So we see in our quadratic formula we have spaces for A, highlight those in yellow, spaces for B, highlight those in orange, and then spaces for C right there in pink. Cool. So we're just going to plug this in. The solution is going to be x equals negative. Now whenever I plug in a variable, I like to open parentheses and just leave a space there because I'm going to fill it with something. But for right now I'm just going to leave it blank. Same thing here with b squared. I don't know what b is yet. We'll get the value in a second. I'm going to fill it in with just parentheses now. Minus 4a and c all over 2a. Cool. So from our equation over here, we see in yellow that we have a equal to 2. So anywhere I see an a in my equation, I'm going to use the same colors, but a is equal to 2. So I'm going to go ahead and plug in my 2's wherever I saw an a. Next we have b. B is negative 5. Let me go through and plug in b's. Negative 5, negative 5. And the last one we have c in pink. One place for that, and it's going to be negative 12. Cool. So at this point we have all of our values plugged in. We just have to simplify this expression down to get our solutions to this equation that we started with here. Alright, so let's take a step simplifying. So x equals, and actually if you would like, you can pause the video right now, try and simplify through a step, and then see if we agree on the video after you fast forward. But if I'm going to go ahead, I'm going to go negative, negative. That makes a positive 5. So 5 plus or minus the square root of, this is 5, a negative 5 squared. That means negative 5 squared is equal to negative 5 times negative 5, which is positive 25. Cool. So 25 minus 4 times 2 times negative 12. We'll do this all at once. 4 times 2 is 8. 8 times negative 12. 8 times negative 12, let me do that out. 8, 6, 96. So we're going to have 96. But there's another negative here. So we have a negative, another negative. That just means positive 96. All over 2 times 2, which is 4. So we've taken a step simplifying. Simplify it down a little bit further. Get rid of that work. We still have x equal 5 plus minus square root of 96 plus 125. 96, 12. It's 121 all over 4. So we get x equals 5 plus or minus. Now this is the square root of 121. Remember, square root's asking us what number times itself gives us 121. If we want to check, I have to know it's 11. We can check on a calculator though. So that's 11 all over 4. Now at this point we have two solutions. Fundamental theorem of algebra says that any polynomial must have as many solutions as it has a degree. So our original equation over here had degree 2. The highest exponent was 2, which means we should have 2 solutions. So it's good in our answer over here that we're getting 2 solutions. I take this a step further, I'm going to get x equal to 5 plus 11 all over 4. That's one of our solutions. The other one is if it's minus, x equals 5 minus 11 all over 4. One more step simplifying, x equals, that's going to be 11 plus 5, that's 16 over 4, which is just 4. So there's a solution, x equals 4. Another solution is x equals, that's going to be negative 6 all over 4, so negative 3 over 2 if we simplify. So there are two solutions. Fundamental theorem of algebra said we needed two solutions to this quadratic. Quadratic formula is what we used to find them, and at the end, sure enough, we did get two solutions.